Good morning, everybody, and welcome to this webinar jointly hosted by Mirantis and Trilio. We're going to be talking about application mobility and disaster recovery. And I'm going to quickly introduce myself, Ben Dorman, and then introduce my colleague, Stefan. I'm based in Victoria, BC, Canada, and Stefan is based in Braunschweig, is it?
Correct. Germany, yes.
Okay, so this is what we're going to do. First of all, it's really important to realize that we're solving real business problems. One of my colleagues in marketing points out to people that people don't go to the hardware store to buy a drill, they go to create a hole, which is what the drill is supposed to be used for. So, in the same way, we're going to tell you what our tools that we're talking about are designed to do. We will try and introduce and tell you what we think is important about what we're saying here. Introduce our tool set, the Mirantis Kubernetes Engine and the TrillioVault for Kubernetes. And then we're going to show you a demo of the two working together to migrate an application between clusters and show how that can be used for disaster recovery. Okay, so on the business problems, and Stefan, please chime in when I forget something here. Clearly, if your servers go down at a critical time, you want to come back up again. You want to create, to have continuity in your business, and you want to make sure that that recovery is as fast as possible. The RTO, recovery time objective, should be as short as possible and meet some kind of service level agreement. Um, the way you move data around is subject to regulatory requirements, and of course security issues such as the need for protect against ransomware. This is one mitigation strategy.
Exactly. Maybe I can add something to it. So these days, one of the biggest issues is, for example, as a service provider, as a e-commerce shop, or whatever service you as a customer offer, people have the choice to go somewhere else much more likely than maybe 10 years ago. So if you remember, for example, the days when you have a certain mobile app on your phone, there's maybe just one or two of them, of these kind of applications out there. And if that is not working because your servers are down, your service is not up and running for whatever reason, they just go somewhere else. These days, maybe it's just a subscription of 1 month or something, and you lose a potential good customer because they're going somewhere else. That's why these kind of business continuity, maybe it's a human mistake, maybe it's a network outage or something you can't actually influence, but you can be prepared for it. So these kind of business problems are to be covered and to be cared of, to keep your customers, because not only losing the customer is a bad thing, it's also very bad because maybe they have produce a bad reputation of your company because the service is always down, you can't keep your SLAs the customer is paying for. This is something you have to consider as well these days, because people just have the choice to go somewhere else.
Yes, and just to add again to stress the importance of being able to recover from a security breach is very much part of what we're talking about here. Um, so if you can go into the next slide. So what are the takeaways here? One of the things that we're promoting is the idea that we should be able to do the same operations, whether we're running on public clouds such as AWS or Azure or on-premise. The idea of cloud native software is to provide those capabilities that we're talking about wherever you happen to be hosted. So there's cloud infrastructure and there's cloud native software, which is a certain kind of architecture running on it, and um, they're somewhat distinct. So we're talking about infrastructure agnostic capabilities here. Also, one of the features that this provides is that the storage is agnostic. Our infrastructure, our applications are written on immutable containers that don't that are stateless, and the storage is somewhere else. And therefore, as long as we have the right way of accessing the storage, technically storage drivers, we can put our storage anywhere, which means that we can also move it everywhere. That's one of the things that makes all of this kind of stuff mobile. Um, so the deployment should be the same anywhere. You're just using Kubernetes manifests or Helm charts, technically speaking. And we're going to show you how the backups can be automated and orchestrated in the cluster framework.
Exactly. To chime in here, Trilio's playing exactly on the same theme. We are running on mostly every cloud which is CNCF compliant. We are agnostic from an infrastructure, from a storage, and also from a deployment perspective, because you need to be agnostic these days to not lock in the customer into a certain kind of infrastructure, deployment, storage combination kind of thing, to be able to be deployed and working on a variety of different distributions and platforms. And also automation and orchestration is a key, because most people have orchestration or automation tools in place, and we have to be compatible to that.
Okay, so now we're going to talk a little bit about the environment that we're working on and demonstrating on. We have two Mirantis products. Well, it's really one and a management layer for it. Mirantis has a distribution of Kubernetes, which runs on all of the platforms that we've talked about. It will run on bare metal, on-prem, in data centers, and in the public cloud. And the Mirantis Container Cloud will see provide some capabilities. And at some point, the there you go. TrillioVault for Kubernetes is an application that Stefan will demonstrate in detail that allows backups in an application-centric kind of way, where you can take a particular application and put all of its data and images elsewhere. And then restore it, obviously. So on the Mirantis side, we have one of our goals is to make it easy to operate Kubernetes on multiple platforms at the same time. For example, I can have the Mirantis Container Cloud, which is our management plane, support clusters, say, simultaneously on premise or in data center, on private clouds such as OpenStack, on public clouds such as AWS, Azure, or AWS or Azure. And what Mirantis Container Cloud does is it manages the life cycle. It creates the clusters with a click of a button, provisions the machines. It provides identity and access management for all the clusters. It provisions, and it provides a built-in logging, monitoring, alerting framework. Not just this is not a whole bunch of proprietary stuff. It's using well-known open source tools such as OpenSearch, Prometheus, Grafana, and Alerta. The Kubernetes engine itself, which is what Mirantis Container Cloud creates, formerly based on the Docker Enterprise Edition, runs on the Mirantis container runtime, which nowadays at the base of it is Container.D. You know about the retirement of Docker, the Docker runtime in Kubernetes. That is a layer that's included, but the fundamental container runtime that talks to Kubernetes is Container.D. Mirantis Container Runtimes runs both on Linux and Windows. MKE supports not just Kubernetes, but also Swarm, and there are a number of companies that have use cases that requires both of them to be working simultaneously. Security is provided. It's past FIPS 140-2 validation. If you don't know what that is, you probably don't need to. But it's the federal information processing standard. And MKE provides a browser-based interface for management of its own that allows various pieces of configuration and view. So let's talk about Trilio now.
Yes, exactly. So what is actually TrillioVault for Kubernetes? And basically what it does. So TrillioVault for Kubernetes is a data protection platform for Kubernetes, obviously, and it is agentless because we don't believe in agents. Agents are not state of the art, and it's not really cloud native. And also, from a security perspective, agents would add kind of an attack surface to the game, and that's not necessary here. If we do backups, it should be non-disruptive. Nobody wants to have proper downtimes to do some backups. It has to be the same way the platform is, a self-service, multi-tenant, and it should be infinite scalable, like the MKE platform itself is as well. Because nobody wants to be the bottleneck. Nobody wants to have downtimes if you want to scale. Nobody wants to do manual work or redeploy work. If you scale out and extend your cloud capabilities and your cloud, for example, compute resources or storage resources, nobody wants that because that is not the cloud native way. And the same way, we are basically running on cloud native Kubernetes platforms. TrillioVault for Kubernetes is designed to run and also designed with these kind of platforms to not be kind of disruptive there. And to add to these kind of cloud native topics here is that we use a open universal backup schema, which adds to the topic of being transparent and being a trusted partner for our customers. What does that mean? We do not use any proprietary self-developed, self-invented data formats to do our backups. It is a QCOD2 image, which is very, very common in the Linux world since many years. If you want to mount a disk, for example, from the OpenStack days as well. So something somebody can use even without Trilio. So if you take a backup, a snapshot of your data from a database, for example, if you're not happy with Trilio, you are not logged into it, not logged into Trilio, so you can mount this kind of image to whatever compute instance to your liking. Because especially in very sensitive areas like military defense and finance and insurance companies, they don't want to have a kind of a black box of their data. They don't know what's in it. They can't scan it. They can't malware scan it. So that's something we don't want. That's why we use this very powerful format of our data backups. So how it works. Very easy example in this case. So Trilio is capable of doing, obviously, this topic is about disaster recovery. So how does that look like? So we have cluster number 1 on the left-hand side, and we have a regular application, in this case, including PV, so it's a stateful application, and we back it up to a target outside of that cluster to be safe once maybe this cluster has an issue or something. So we have backed this up, and we support NFS and S3 targets. So basically what speaks NFS and S3 could be used for as a backup target. And everything which is necessary, and I point this out and highlight this, everything which is necessary to recover from an outage and basically restore your application is lying on that target. So in case cluster number 1 in that application, there's an issue, somebody has deleted something, or you don't trust this environment anymore, you just want to restore to a backup namespace, for example, you can do that. You can do a restore of the entire application, or you can just restore bits and pieces of it because you know exactly what went wrong. Maybe the PV is somehow malformed. Just restore the PV with data. Maybe some Kubernetes config items like secrets or config maps. You can basically pick and choose what you like to be restored. So, but now we're coming to the more urgent case. So this cluster is down, it's not reachable, it has been misconfigured, or maybe you are a victim of a hacker attack and you don't trust this cluster anymore. You don't want to use it anymore. What you can do is spin up a new cluster or have a cold standby cluster available somewhere. Have this cluster kind of a from scratch installed cluster somewhere, install Trilio on it, which takes maybe 5 minutes. It's just a one Helm command or similar to that, and let Trilio know where is my backup. That's the only thing you have to remember. It's basically the access credentials for your S3 bucket, for example, or the path to the NFS. That's the only thing you need to remember, to give Trilio access to that repository. And once this is done, you are able to recover from that outage. You can restore all the things because Trilio is browsing through that backup target, and you can pick and choose what kind of backup and what kind of data you would like to restore. The bottom line of this slide is that Trilio itself is a stateless application. So there is no need to do backup the backup application. Everything you need for your application, and that is the most important part here to save time as well, is on that target. Just install Trilio and tell them where the backups are. That's it. Okay, now we're coming to the basically play here in the entire Mirantis ecosystem. So Trilio itself do not only support the backups of Kubernetes workloads running on the right-hand side on the Mirantis Kubernetes Engine, MKE. We also support Mirantis OpenStack, which is, as Ben already mentioned, orchestrated and automated via the Mirantis Container Cloud functionality, and it can run basically everywhere. You see that in the middle, just as some examples. Basically, for every customer, there's a kind of infrastructure provider available, and this is surrounded by all the Mirantis kind of framework tools like Stacklight and Lens and the registries and container runtimes, whatever you need for the entire play of playing with these infrastructures. So basically here in this case, we support both sides, both orchestrated by Mirantis Container Engine. So we're playing in that ecosystem, so you can use us. If you're a Mirantis customer or a potential Mirantis customer, you can use us and orchestrate that with the existing Mirantis toolset, so to say. As an example, I just mentioned it, pointing out to Mirantis Lens. Without doing anything to Lens, once you have gave the Lens access to your Kubernetes cluster, you are also able to see on a kind of a visibility layer all the custom resources and activities Trilio has done on your cluster. For example, seeing here in this case, backups in certain namespaces, so you can basically view and observe what's going on, what kind of size is used, and you can dig in and do whatever you can do with Lens on the Trilio perspective here. So without any extension, because Trilio itself is just an extension to the Kubernetes API, and Mirantis Lens is, obviously capable of handling all the Kubernetes API functionalities, and Trilio is just one of them. That's why out of the box, Trilio is basically supported by Mirantis Lens here in this case. So as I mentioned, if you are operating with Mirantis Lens, you're doing a lot of stuff in your company, you can do this with the Trilio perspective as well. Okay, I mentioned it as well many times, framework and existing tool sets, these kind of things, because they are very important. Because Trilio is just a small puzzle in every enterprise kind of tool set or framework or whatever you want to call it, enterprise architecture. So we are not a malware and virus scanning tool. We are not a key management tool. We are not a observability tool. We are not a cloud storage provider and not a reporting and metrics tool and not an automation orchestration tool. And marketing hates that if I say that, because that is actually something we are not. We are a data protection platform. We do and we stick to our business. That's what we do, and that's what we do perfectly. But in every enterprise architecture, these tools are already existing, hopefully. And we have to be able to leverage them to enrich Trilio. For example, if you have an Okta authentication provider in place, and you would like to use it for Trilio as well, obviously, because it's one process, one authentication provider is always good than having a third one provided by Trilio. That doesn't make sense. So we are compatible to these different tool sets, like malware scanners. I mentioned it before. We have a QK2 image, which you can obviously scan. Just let your scanners know how to do that. Key management system as well. So if you have a CyberArk or a HashiCorp Vault or similar tools in case of Prometheus and Grafana, Stacklight for observability, Trilio is compatible to that and can interop with these kind of tool sets. That's the That's the bottom line of this slide here. So that is something very important in this case, because otherwise, if we would deliver all of these tools on our own, the integration costs, maybe because most companies have these tools already in place, would be immense. So the integration cost of a tool like Trilio must be very, very slim as well to be able to be used in an existing ecosystem. So obviously, the use cases of TrillioVault, backup and recovery. I mentioned it before. That's the traditional use case. Also disaster recovery. We will see this later in the video as well. And also the application mobility topic. And for Trilio, these three things are actually the same function. It's the same process we use to do so. But behind that is just an urgent case, because we move data, no matter if it's from one cluster to the same cluster, from one cluster to another cluster, or in application mobility, in case of maybe you have an upgrade, major upgrade, you would like to test your new platform first and then migrate the data on. That's all good, but from Trilio perspective, it's all the same functionality, because we move data from the backup target somewhere. So it's very slim, very kind of easy for Trilio. So you don't need 3 products or 3 features or something like that. It's the same feature. You just have to let Trilio know where should this backup go to. I mentioned it before for migration scenarios, as well as normal disaster, or just you want to move applications from A to B. And a good example is also ransomware attacks. So we also support encryption for your backups, for your entire backups, basically, and also ransomware protection with the object locking functionality. So this means once you got this backup on your target, it will be basically locked for a certain amount of time you have defined, and nobody can delete, edit, adjust, or somehow double encrypt like ransomware attackers do your backup. So you're safe from this perspective as well. Maybe as a scenario for application mobility, it's a very interesting one. We have customers using Trilio in terms of application mobility for forensic things. So they develop honeypots, and they move these honeypots, basically mobilize these honeypot softwares to open Kubernetes clusters all around the world. And hackers and these scanners out there, they find these honeypots, they try to hack this for whatever reason, and this company is then backing it back up and try to analyze how these hackers basically attack these honeypots. So quite interesting approach. Okay, coming to our demo. Exactly. So what will we see in our demo? I have a short overview for you guys. So what we do is we have obviously the application on a different cluster. It's an OpenShift cluster, and we disaster recover it to Mirantis MKE Kubernetes cluster. We will see that we are capable of something called transform. So it's kind of a restore transformation. And what does that mean? We are able to give you the power, like in DIY store, to edit and adjust all metadata of your backed up application before you restore it somewhere, for multiple reasons. Maybe it's a different platform, it has a different storage class. Maybe you would like to change it from node port to load balancer. You would like to change the service port. Whatever is described in the metadata, basically JSON files we have backed up for you, you can, in a kind of an easy, comparable fashion, manipulate, modulate, whatever you want to call it, because you know exactly where your backup should go to, and you know exactly your platform. So you can do the certain tweaks yourself. It's a very powerful feature. So you are basically preparing your backups for whatever cluster you have, because you never know. Maybe there's a super high sophisticated new functionality you would like to use, and you would like to shift to a different cluster. You are able to basically prepare your backups, even they have been backed up on a completely different distribution somewhere. And yeah, we will do so. We will back up an application. It is a WordPress application, because a stateful application, and we will restore it. So basically, we move it to an MKE cluster, basically on the other side. So you see, we have added. So TrillioVault is offering a multi-cluster UI. If you want to use the UI, we also have a fully blown API, and we have a CLI, and also you can include us into your CI/CD pipeline system. But also, if you're using Ansible, Terraform, Chef, these automation tools, whatever the only thing you need is that it is compatible to Kubernetes, as I mentioned, and then you can use Trilio as well. So in this multi-cluster UI, I've added our source cluster, the OpenShift cluster called Red Hat Open OCP demo, and we would like to use the target cluster here, MKE cluster demo, to receive our application, our WordPress application. So for that, we click in our OpenShift cluster and into our demo namespace. You'll see there's the demo namespace, and obviously, this video was made for KubeCon, and here we go. We have our WordPress application running on an OpenShift kind of URL, and our beautiful KubeCon demo blog post I have created. And what we do now is we will go ahead and take a backup. Just click on the action button, say create backup, and what we have to do first is create a backup plan. A backup plan is nothing else than a policy. We define what namespace we are currently looking at, what is the target it should go to. You can add an encryption secret for obviously encryption reasons. We can also discover if you have Helm-based applications running in that namespace. So we would, if we identify that, we could also already back up the Helm charts for you, so you do not lose the Helm revisions you have done probably. We have something called hooks we can enable here. If you have, for example, database running, you can execute a hook to execute commands against the database. And there we go. Go back into the create backup. So we create a backup plan again. Give it a name to use this backup plan later on again, if you like. So that's our AWS S3 bucket we use as a target. And we go ahead and create that backup plan. Takes a second, and our backup plan has been created. So what we do now is, based on the backup plan, we trigger the actual backup. Again, we give it a name, and every first backup is always a full backup. We also increment after the first full backup. We also support forever incrementals to save storage capacity and these kind of things. So you see here we have done a meta snapshot of all the metadata, and we have also done a snapshot of the actual data as a QCode2 image. So we converted it into a QCode2 image, and we uploaded both of them to our destination target. In this case, in AWS, as I mentioned before. We see the PV claims here, which we have taken a backup of, and then we uploaded it. So what we now do, we play hacker, and we basically change the demo block to a hacked demo block. So basically, I'm a successful hacker here, and it has been hacked. And as I mentioned before, we don't actually trust this cluster anymore because it has been hacked and nobody knows what has been compromised. So we change to our MKE, to a clean, fresh installed MKE cluster. And what we do is we go into our demo namespace here, and there's nothing in it. It's an empty one. There's two options. You can create this namespace beforehand, but also you can create this namespace during the restore procedure if you like. So what we do now is we go, as I mentioned before, we just give it a target where Trilio should look for our backups. And in this case, we do a disaster recovery plan, and we give it a name. And then, as I mentioned before, the select target is the key functionality here. And as you see here, we give it a target, and it is already finding 4 different backup plans. And in this case, we are looking for our WordPress application backup, which is, there we go. Stefan or KubeCon demo block WordPress, and we can select exactly this backup. In this case, we just select this one. You can select multiple if you like. And now we are coming to this, I call it the DIY store. And you see in the restore configuration in the first tab that we have the option to give it that restore a name. And we also can select the namespace where we would like it to be restored. And then we have a lot of switches there. For example, if there's something already in, you should skip it, patch the CRDs, for example, clean up on failure. So there are a lot of things which are quite useful. But I always like to point out the so-called protect restored app functionality is the fourth last in the section. And what it actually does is very, very beneficial for customers. If you do, for whatever reason, this disaster recovery on a failed cluster, for example, this switch, if you select it, it will already protect or right away protect the restored application with the same backup plan you have used before to back up the application. So the outcome would be you restore the application is up and running, and it's automatically protected, so you don't have to recreate the backup plan again. It's already reusing the backup plan you have used beforehand. So Trilio's right away protecting this application again, because you never know what happened in your infrastructure, so you can take it back up right away without maybe putting some effort in designing and creating the backup policy for that application. So now, because we are coming from a OpenShift cluster, which is obviously different, and in this case, we are looking at storage classes and things, we have this transformation component area. And what we would like to do here is we would like to say, hey, this is an MKE environment, and for some reason we have a different storage class here. We would like to change that because we know that the what did we use? I think it was a ODF or OCS on the OpenShift side. We would like to create a transform for it and correct this wrong storage class in this case. So on this MKE cluster, for visibility reasons, we use the CSI host path storage class driver, and we would like to replace the existing one. And the good feature is a so-called preview changes visibility feature we have implemented. And maybe it's hard to read because it's small letters here, but you see on the left-hand side the original configuration, which was an OCS, as I mentioned, and on the right-hand side, the transformed resource. And I mentioned before that this is just an example, I mean, a very powerful example, but there are everything which you see here can be transformed or changed to your liking for certain reasons. So very powerful tool set, and this preview visibility shows you that you don't make a mistake. So maybe you have a typo in there, it will show up an error saying, hey, this object is not there, this path is not valid, for example. And this is what we do. So now we have basically inserted this transformation, and we will kick off the actual restore. So the restore works the other way around. So the backup is taking the metadata first and then taking a snapshot of the data. The restore is working the other way around. So we prepare the data there, we spin up the metadata areas of pods and PVs, and then we connect the PV the pods to the existing persistent volume. So now we are on the restore has been done. We go into our restored namespace. And what we see in a second is we have our WordPress application running, and we see the number of resources is 5 because it uses 5 different Kubernetes objects. So that has worked. So what we do now is, because this is a different cluster, we will see on the command line as well all the Kubernetes objects we have just talked about. What we do, we will use the new URL we have defined for our KubeCon demo block application, and voila, our KubeCon demo block is back. And the restore has been done successfully, which is obviously a great thing.
If that's the case, we can bid you goodbye, and I imagine that the recording of this session will be available shortly, and you have the Mirantis.com and Trilio.io are our company URLs. Thank you for your attention, and season's greetings to everybody.
Bye, everybody.